In the vast, silent expanse of the cosmos, humanity has always looked up and wondered, are we alone? By 1977, this question was no longer just philosophical. It had become a scientific quest, a search for extraterrestrial intelligence. At the heart of this search was a colossal instrument, listening patiently to the whispers of the universe. This was Ohio State University's radio telescope, affectionately known as the Big Ear, a sentinel in a quiet field. Its mission was simple yet profound, to scan the heavens for any signal that wasn't born of nature. For years, the Big Ear listened. The cosmos returned only the familiar hum of background radiation and distant pulsars. The data it collected was processed by an aging IBM computer, printing out columns of numbers on continuous paper. Each number represented a slice of the sky, a measure of radio intensity. Mostly, the numbers were low. The scientists and volunteers who reviewed these printouts were searching for an anomaly, a spike in the cosmic noise. Then, on a hot summer night in August 1977, something extraordinary happened. The universe decided to speak. The Big Ear was not like modern radio dishes. It was a fixed design, using Earth's rotation to scan the sky. It consisted of a massive, flat reflector the size of 3 football fields and a smaller curved focusing reflector. Radio waves from space would bounce off the flat plane, then be concentrated by the curved dish into a receiver. This ingenious, cost-effective design allowed it to survey huge swaths of the sky with incredible sensitivity. Inside the control room, the atmosphere was one of quiet dedication, filled with the low hum of electronics. Researchers would monitor the equipment, ensuring the silent observer was functioning perfectly through the night. The data wasn't viewed in real time. It was collected, processed, and printed for later analysis by volunteers. This delay between observation and discovery would become a crucial part of the story that was about to unfold. The telescope was specifically tuned to the waterhole frequency, around 1420 megahertz, a quiet channel in the galaxy. Theorists believed this frequency, the emission line of neutral hydrogen, would be a logical choice for an interstellar beacon. The night of August 15, 1977, a warm, clear summer evening in Delaware, Ohio, the world was oblivious. As the Earth turned, the Big Ear's gaze swept across the constellation Sagittarius, a star-rich region toward the galactic center. For a fleeting moment, a radio source in its field of view began to grow unexpectedly, unnaturally loud. The signal was incredibly strong, 30 times louder than the background noise of deep space, a true cosmic shout. As the telescope's view continued to pan across it, the signal peaked and then faded, precisely as expected. The entire event lasted just 72 seconds, the exact time it took the Big Ear to scan a single point in space. The powerful, transient burst of energy was captured, converted into numbers, and sent to the printer. It lay hidden in a stream of mundane data, a message in a bottle floating in an ocean of paper. No alarms went off. No one in the control room knew what the telescope had just witnessed. The night continued, the Earth kept spinning, and the Big Ear kept listening, its moment of discovery now in the past. A few days later, the printouts from the telescope were collected for review, a routine task for the project's volunteers. One of those volunteers was a 37-year-old professor named Jerry Ehman, who took the data home to analyze. He sat at his kitchen table, surrounded by stacks of paper, a red pen in hand, scanning endless columns. The computer encoded signal strength with characters, numbers 1 through 9 for low intensity, then letters for higher values. He was looking for anything above a 4 or 5, a slight deviation from the norm that might warrant a second look. Page after page revealed nothing but the expected static of space. The cosmic hum was monotonous, predictable. Then, his eyes caught a sequence of characters so unusual it seemed impossible, a complete aberration in the data. In a sea of 1s and 2s, there was a sequence that read 6EQUJ5. It leaped off the page. His methodical scanning stopped. His heart likely skipped a beat. This was not noise. This was something else entirely. In that quiet moment, at a kitchen table, a discovery was made that would echo through decades of astronomy. Staring at the sequence 6EQUJ5, Jerry Ehman grabbed his red pen. He had to mark this. He had to validate it. He drew a circle around the 6 characters, isolating them from the mundane data surrounding them, a beacon in the noise. The characters perfectly represented a signal rising in intensity, peaking, and then falling as the telescope passed by. He checked the coordinates, the time, the frequency. Everything pointed to a celestial origin, deep in the Sagittarius constellation. It wasn't a satellite. It wasn't terrestrial interference. The signal's profile was exactly what they were looking for. Overcome with a mix of shock and excitement, he wrote a single, spontaneous annotation in the margin. 3 letters that would perfectly capture the monumental importance of what he had found. Wow! That simple human reaction gave the signal its name, a name that would become legendary in the annals of science. The wow signal was born, a 72-second whisper from the stars that posed the biggest question of all. Ehman immediately contacted his colleagues. The quiet search had suddenly become an urgent, electrifying investigation. So what did 6EQUJ5 actually mean? It was a code for intensity. 6 meant 6 times the background noise. The letters represented even higher levels. E was 14 times, Q was 26 times, and U was 30 times the background. The peak intensity, represented by U, was an astonishingly powerful burst, far stronger than any known natural source. Then, the signal faded symmetrically, JI for 19 times, and 5 for 5 times the background noise. This perfect rise and fall was the exact signature expected from a fixed source being scanned by the telescope. Furthermore, the signal was incredibly narrowband, occupying a tiny sliver of the frequency spectrum. Natural cosmic sources, like pulsars or quasars, typically broadcast over a much wider range of frequencies. A narrowband signal is far more efficient for long-distance communication, suggesting an artificial, intelligently designed transmitter. And its frequency was almost exactly at the hydrogen line, the universal marker astronomers had hoped for. Every single characteristic of the wow signal pointed towards something extraordinary, a potential message from another civilization. The astronomers rushed to pinpoint the signal's origin. The data pointed to a patch of sky in Sagittarius. This region is dense with stars, lying in the direction of our galaxy's core, a fertile ground for speculation. There are no bright, obvious stars at the precise location, just a few faint ones, making the source hard to identify. The team's first priority was to rule out all earthly explanations. Could it be a simple mistake? They checked for military or commercial satellites. None were in that part of the sky at that time. Could it be a reflection from a piece of space debris or even a high-altitude aircraft? Unlikely. A reflected terrestrial signal wouldn't have the perfect characteristics of a fixed celestial source scanned for 72 seconds. The signal was only detected in one of the telescope's 2 feed horns, further deepening the mystery of its position. After exhausting all known possibilities, the astronomers were left with a startling conclusion. The source was not from Earth. It came from beyond our solar system, from an unknown point dozens, hundreds, or even thousands of light years away. The discovery triggered an immediate and intense follow-up. The most crucial step was to find the signal again. John Krauss, the director of the observatory, and his team immediately trained the big ear back on that patch of sky. For the rest of the month, they listened. They scanned the coordinates over and over, hoping to hear the echo. The printer churned out more paper. The oscilloscopes displayed their green lines, but the signal was gone. There was only silence. The cosmic shout had faded back into a whisper, leaving only questions behind. In the months and years that followed, dozens of other searches were conducted by observatories around the world. Using more powerful and sophisticated equipment, they stared at the source coordinates for hundreds of hours. The result was always the same: nothing. The signal had been a one-time event, a fleeting moment of cosmic significance. This lack of repetition is one of the signal's most tantalizing and frustrating aspects. Why broadcast only once? It was like receiving a single perfect word from across an ocean, only to be met with an unending silence. Decades have passed since that August night. Jerry Ehman and the original team have aged, and the big ear is gone. The telescope was disassembled in 1998 to make way for a golf course expansion, a quiet end for a legendary instrument. Yet, the data it collected on that single night continues to fascinate and baffle scientists to this day. Many theories have been proposed to explain the signal without invoking extraterrestrial intelligence. None are perfect. One idea suggests a rare glint off a piece of space junk, but this fails to explain the narrow band frequency. Another theory proposed the hydrogen cloud of a passing comet, but comets weren't in the right place at the time. Some have suggested an unusual astronomical event, like a gravitational lensing effect or a rare type of pulsar. But even these natural explanations struggle to account for all the signal's unique characteristics simultaneously. With every natural explanation falling short, the most tantalizing possibility, however unlikely, remains on the table. The silence that followed the signal is perhaps the most profound part of the mystery. Was it a greeting, a warning, or just a fluke? Today, the wow signal is more than just a historical footnote. It's a symbol of both hope and mystery. It represents the best candidate we have ever found for a genuine extraterrestrial transmission. It reminds us that extraordinary things can be hidden in plain sight, waiting in a stack of old papers. Perhaps it was a one-off beacon from a civilization that has since gone silent, a cosmic lighthouse sweeping past us. Maybe it was a message not meant for us, an interstellar conversation we just happened to overhear for a moment. Or perhaps it was a very, very unlikely combination of natural phenomena that we still don't fully understand. The truth is, we may never know for sure what sent that 72-second message across the void. But its existence has fueled our imagination and our scientific curiosity for nearly half a century. It serves as a powerful reminder that the universe is vast, mysterious, and potentially full of surprises. And it compels us to keep listening, to keep searching for another wow moment among the stars.